I'd like to continue our discussion of qualitative research by talking a little bit about content analysis. This is similar to grounded theory, but is more relaxed, more generic, and may be applicable to more cases. On the other hand, it's certainly less rigorous in the way that it's defined than grounded theory is. And this was described, this material comes from Lazar's 2010 book on research in HCI. The 2017 edition is similar and is available at the library or my courses. So the definition of content analysis given in Lazar et al. Is systematic replicable technique that compresses words into content categories based on explicit rules of coding. And this definition limits content analysis to text, but not everyone agrees. So a broader definition would be any technique for making inferences by objectively and systematically identifying specified characteristics of messages. And messages could be text, they could be drawings, they could be music, they could be video, or more. So it's an in-depth analysis searching for theoretical interpretations. And it embodies well-constructed themes and categories, the development of context, the development of explanations of process or change over time. And it is both qualitative and quantitative. But before we delve into it in more detail, we have to ask the question, what is content? So there are two categories of content identified by Lazar. The first one is public content, and the second is private content. Public content is content that anyone can access, so anything that's on the web, for example. Private content consists of surveys, questionnaires, interviews, focus groups, diaries, or observation, things that you have control over the dissemination of. Now, why would you collect content? Well, you can't get information otherwise, and you don't know in advance what to look for. So there are some questions that you have to consider before you do content analysis. You have to define the data. You have to define the population. For example, suppose you decide to study community members in an online context. How do you define community members? Do community members include lurkers or just those who post in an online community? You have to define the context. So, for example, suppose you study attitudes towards security. A government worker's context includes a lot of training and severe consequences for security breaches, while someone in private enterprise may not receive any training and may face few or no consequences if they're responsible for a security breach. Interpret words in context. So after defining the context, you have to be able to interpret what you get in that context, and not just words, but other types of evidence. And analyze text content, and the text can be actual text, or it could be, again, some other media. And this process is called coding, like in grounded theory. And coding is more than paraphrasing, but less rigorously defined than it is in grounded theory. So coding is more than just counting keywords, and there are different approaches to coding. And here are two approaches that are suggested by Lazar. One is a priori, and the other is emergent. So in a priori coding, we identify the categories before we code the data. We then code the data using more than one coder, and then do a reliability check to see if the coders agree on the categorizations. And this is very good for topics that are studied, that have been studied before, because the related literature is often sufficient for the establishment of categories. Emergent coding is a good method if there is no related literature to draw on for categories. And here, of course, you generate the codes as you go along. Again, you use multiple researchers, and each codes a subset, and then you compare lists. These are lists of categories, by the way. You consolidate the lists of categories, and there should be agreement among the researchers about the final set of categories. Next, you code using the new list, the consolidated list, and multiple researchers code independently using it, and you evaluate inter-rater reliability. And it is common to use Cohen's kappa to evaluate inter-rater reliability. That's the most typical measure, and I'll show you a formula for that later. And you repeat as needed. If Cohen's kappa is below 0.7, then researchers need to code again. That's a common rule of thumb, and you may find different communities that have different thresholds of Cohen's kappa, and some use other measures as well, but that's the most common. Okay, coding categories may come from several sources. They may be existing theoretical framework sources. They may be the researcher's interpretation, or what we would call research-denoted concepts. And there may be in vivo codes, so these would be original terms provided by the participants. The existing theoretical framework. So, for example, senior citizens using computers. The theoretical framework could be the human capabilities literature. And there would be capabilities categories, including cognitive, physical, and perceptual. And you could code all the problems that senior citizens have with computers into these three categories, just as an example. Another example is task types. So Don Norman developed group tasks into the following categories: structured versus unstructured, and regular versus intermittent. So for example, mistakes and slips that Norman talked about in later work, and the slips included capture errors, description errors, data-driven errors, associative activation errors, loss of activation errors, and mode errors. Then I mentioned the researcher-denoted concepts. So you make up the terms, you decide what's interesting, and you decide what constitutes a pattern. And of course, the in vivo codes. The participant provides a useful term, and that term identifies a pattern. So then you build a code structure, which is a hierarchical list, also called the nomenclature. And the coding process is to read first and then code, and reading through all the text to be coded before making any notes if possible. This is quite different from grounded theory, by the way. And there are inexperience issues with doing this. So two big inexperience issues are reluctance to code anything and the impulse to code everything. So those are both potential problems that you have to get over when you're first starting out. The steps to follow to avoid the too much or too little pitfalls are to first look for specific items and to ask questions constantly about the data and to make comparisons constantly at various levels. This is, of course, very similar to grounded theory. So looking for specific items. So examples would include objectives, actions, outcomes, consequences, causes, contexts, and strategies, with actions perhaps being the most prevalent. Asking questions constantly about the data. Sensitizing questions. What is happening here? What did a person click? How did a person get here? Theoretical questions. What is the relationship between two factors? For example, how does the interaction change over time? And third, making constant comparisons at various levels, comparing frequencies, comparing impacts, comparing groups, comparing to previous reports. Okay, analysis quality depends on a couple of things: validity and reliability. Validity is defined by Lazar as documentation of procedures. So we know it's valid because you said exactly how you did it, and that seems like a valid approach. And the preponderance of data that supports the conclusions makes it seem valid. Now, I'm not satisfied by Lazar's account of validity, and I think there are better sources, many of which are pointed to by the Wikipedia article on validity. So my suggestion would be to read the Wikipedia article on validity and go to the sources that it points to. The second is reliability. And reliability consists of stability and reproducibility, so let's define what those mean. So stability means, does the same person always code the same way? And reproducibility means, do different people code the same way? Okay, so we want the coding to be stable and reproducible. And as I mentioned before, it's often the case that we use Cohen's kappa in this method. And here's Cohen's kappa. PA is the percentage of cases agreed upon, and PC is the percentage of cases agreed upon by chance. So in fact, if you don't have if you choose the categories randomly, let's say that both judges choose the categories randomly, well, you would still have some agreement by chance. So you have to factor that out when you're trying to figure out what the true inter-rater reliability is. That's really the best way I can think of to explain that. So let me go back to that for a second. We have the percentage agreed upon minus the percentage that would be agreed upon by chance. So that's just a calculation based on the number that you have, and the number of cases and the number of judges, and divide that by 1 minus the same thing, the percentage agreed upon by chance. Okay, so that's a little bit of a stumbly explanation, but hopefully you get it. So that's the end of content analysis. As I say, it's a more general, more generic, less rigorous, but perhaps more widely applicable method than is grounded theory. So thank you for your attention, and I look forward to seeing you in lecture. Bye.